By controlling the analog gates, we change the frequency of the oscillator. In this experiment, analog switches are used to vary the resistance value that determines the frequency of an oscillator, carried out with NAND gates. Let's make a 4-note organ. The keys act on electronic switches that switch resistances. Operation. As you can see, the basis of the circuit is an oscillator made with NAND gates. To obtain different frequencies, what we are going to do is vary the resistance that sets the oscillator frequency. The circuit has 4 keys, P1, P2, P3 and P4, which directly control the control inputs of the analog switches, so that each time we press one of them we activate that switch. If we press P1, we will close U2A and R2 will be the resistance that forms part of the oscillator. If we press P2, we will activate U2C and the oscillator resistance will be R2 plus R3. Pressing P3 supposes to activate U2B and modify the oscillator resistance to R2 plus R3 plus R4. Finally, if we press P4, we will activate the oscillator resistance, which in this case will be the total sum of R2 plus R3 plus R4 plus R5. The circuit. As we have seen, the basis of the circuit is made up of digitally controlled analog switches. When the control input, terminal C, of these switches is at a low level, between terminals A and B there is a very high impedance and therefore we have an open circuit. However, if the control input is high, between terminals A and B there is a very small resistance, a few ohms, so that terminals A and B are considered to be connected. This property is used to connect the resistances between the points we want on the oscillator. Resistors R7 to R10 are used to ensure that the control inputs are at low level when the keys are not pressed, therefore keeping the switches open. When no key is touched, the oscillator does not work, as there is no resistance in the oscillation circuit. Putting it into operation. If the circuit does not work when one of the keys is pressed, the 4066 connections and power supply must be checked carefully. It is also important that we review the polarity of the transistor and the power supply of the integrated one with which we built the oscillator. If everything is fine, there shouldn't be any problems, because the circuit does not have any critical points. Experiments. Each of the frequencies that make up the organ is formed with resistors R2 to R5. Therefore, modifying these frequencies simply involves varying these resistances, thereby changing the sound that the speaker emits.